In this lab, we will be identifying an unknown over-the-counter analgesic, a fancy word used for drugs that are pain and fever reducers. You'll be given an unknown analgesic that is either Anacin, Motrin, Tylenol, or Excedrin, which are made up of the compounds seen here. We can identify which analgesic we have by identifying the individual compounds through thin layer chromatography, or TLC. TLC separates compounds based on how they interact with the stationary phase, a film built of polar molecules, and the mobile phase, a nonpolar organic solvent. The effect is what you can see here on this TLC plate. As the nonpolar mobile phase runs up the plate, compounds that are more polar don't travel as far because they have stronger interactions with the polar stationary phase than with the nonpolar mobile phase. The opposite is true for nonpolar compounds that get pulled farther up the plate by the nonpolar solvent. We can compare the positions of known compounds on the plate with the positions of the components of an unknown mixture to identify that unknown.
So these are the compounds you're going to be using in lab today. They are ibuprofen, acetaminophen, caffeine, and aspirin. And a few of you are going to be asked to make these solutions for the rest of your classmates today. Weigh approximately 10 milligrams of each known compound and transfer the compound to their individual screw cap vials. To each of the known compounds, add a few drops of methanol to dissolve the compound. Take a piece of paper and label each known compound. Place the vial next to the corresponding compound.
These are the micropipettes, the spotters that you're going to use to spot your TLC plate. There's a cap, but you don't need to unscrew this. There's a little hole in the top. And so kind of like a salt and pepper shaker, you just shake it until one of them comes out. And each of these spotters needs to stay with the compound that you start with. Don't mix the spotters up for each of the compound.
Each solution should have its own spotter. Make sure not to mix these up. Like we did with the known compounds, you're going to weigh out 10 milligrams of your unknown compound and place it into a screw cap vial. A few drops of methanol to your unknown. Your unknown next to its label and add your capillary spotter.
In each of the vials you make, there's going to be some undissolved solid, and that's okay.
Okay, so what you're looking at is a TLC plate. One side contains a silica gel while the other side is plastic. You can touch the plastic side, but make sure not to touch the silica gel as it can contaminate it. Always handle the TLC plates with care.
So what you're going to do to set up your TLC plate is you're going to make a dotted line about 1/2 centimeter from the bottom. Then you're going to make 5 tick marks corresponding to our 5 solutions. The unknown always goes in the middle, and then the other 4 will go on the sides. Now you need to keep track of what solution you're going to spot on each of these lines. So you know the unknown goes in the middle, but if you want to put letters underneath each one to keep track of it, say this is caffeine and this is aspirin or something like that, you can do that. You can put them in alphabetical order, but you just need to be able to keep track of which spot is which solution.
Before we add our solvent to the beaker, we need to make sure that our TLC plate actually fits with the lid on. So go ahead and put your TLC plate into the beaker and test it. Generally a 150 milliliter beaker works.
Now we need to make our mobile phase for our TLC, which is made up of 1 part petroleum ether, 1 part methylene chloride, and 2 parts ethyl acetate. We're going to use just 1 mil, 1 mil, and 2 mils. Because these are organic solvents, they will evaporate pretty quickly, and so when you're not using the solvent, you need to make sure that it's covered. Now we want the solvent to start on the TLC plate below where our spotted compounds will be, which will be on this line. And so you need to hold up, whichever beaker you're using, you need to hold up your TLC plate next to it with the solvent inside to make sure that the line of the solvent is below the line on your TLC plate. And you can see that ours is just a little bit below, so we're good. Now, one thing before you start spotting to remember is that the order that the person preparing these solutions has set these up is most likely not the order that is on your TLC plate. See, mine is in alphabetical order with the unknown in the middle. And so I'm going to have to make sure that I put the right compound with the right position on my TLC plate.
To load your TLC plate, take the spotter and one of your samples. Place the spotter inside the vial. You may have to tilt the vial. Because the liquid is clear and the spotter is so small, you probably won't be able to see the spotter full of sample, and that's okay. Remove the spotter and touch one end to its corresponding place on the TLC plate. Repeat this process for the rest of the samples.
Now we're ready to run the TLC, and so we will take our TLC plate, take the watch glass off, and set it carefully inside the beaker. We really want to make sure you understand what's happening here. The mobile phase runs up the plate with the stationary phase bound to the plastic. You can't see the compounds until we put the plate under UV light, but how far each compound travels depends on how polar it is. The more polar a compound is, the less it will travel up the plate. Now that the solvent has run up the plate, we're going to carefully take it out. And this solvent is going to dry really quickly, and we want to know the distance it has traveled for our RF value. So we're going to put a line where it stopped.
After you removed the TLC plate, you're going to shine some UV light on it. You're going to see some dark smudges, so take a pencil and mark those dark smudges. Don't forget to put a dot in each of the smudges to where you think is close to the center of mass.
Okay, now we're going to identify our unknown. And how you do that is you look at each of these lanes that you've circled and the shape of the lane, and you look at your unknown and you say, which of these added together would create the shape that looks a little bit like our unknown lane? And judging from ours, it looks like we've got acetaminophen, aspirin, and caffeine within this lane. Looking at the chart, the table on the lab procedures, it looks like we have Excedrin. To calculate the RF values for each of these compounds, you take your ruler and start it at the line where the solvent began. And you'll calculate the RF by taking the distance the compound traveled divided by the distance the solvent traveled.